Chances are you've already used AI today. Maybe you asked ChatGPT to help draft an email, or you played around with Midjourney to create some digital art. Perhaps you simply checked the weather or set a reminder using your phone's built-in assistant. AI is woven into our daily routines, often in ways we barely notice. These tools feel effortless, almost magical, just software running somewhere in the cloud, always ready to help. But behind every seamless interaction is a hidden world, a vast network of computers working around the clock, consuming enormous amounts of electricity to make these AI experiences possible. The reality is, what seems like a simple app on your device is powered by massive data centers, with a real-world appetite for energy that's hard to imagine. This isn't just a small uptick in server usage, it's a dramatic surge, so significant that it's starting to reshape the global energy landscape and force us to rethink how we power our digital lives. By 2027, experts predict that AI could consume as much electricity as an entire country, think Sweden or Argentina. That's a staggering comparison, and it's not some far-off scenario. This is a challenge we're facing right now, as AI adoption accelerates across industries and into our homes. Data centers were already among the world's biggest energy users, but the rise of AI is supercharging demand to unprecedented levels. Tech giants like Google, Microsoft, Amazon, and Meta are locked in a race for AI dominance, and electricity is the fuel that powers their ambitions. Every new AI breakthrough means more servers, more cooling, and more power. This raises urgent questions about our infrastructure, the environment, and whether these companies can keep their bold sustainability promises as their energy needs skyrocket. They've invested billions in renewable energy, solar farms, wind turbines, and more, but the explosive growth of AI is putting those commitments to the test like never before. The demand for power is now outpacing what wind and solar can provide, forcing tough, sometimes controversial choices about where our energy comes from and how it's used. But why is AI so power-hungry? What's happening inside those server racks that makes them devour so much electricity? And how are tech companies scrambling to secure enough energy to keep up with the relentless pace of AI innovation? We'll explore everything from nuclear and geothermal to new energy technologies, and see how the world's biggest companies are rethinking their power strategies. The big question, can they power the future of AI without breaking their climate promises, or will the energy demands of AI force a new reckoning with our environmental goals? This isn't just a story about technology or big business, it's about everyone who uses the internet, and the choices we all face as AI becomes a bigger part of our lives. Let's dive in and see what the future holds. Why does AI need so much power? It's a question that's becoming more important as artificial intelligence becomes a bigger part of our daily lives. Running a simple app on your phone or laptop barely sips electricity. Most of our everyday devices are designed to be energy efficient, using just enough power to get the job done. But training a large language model is a whole different story. Imagine editing a million 8K videos at the same time, without ever taking a break. That's the kind of relentless high-powered computing we're talking about. These AI models are built with billions, sometimes even trillions of parameters, tiny mathematical weights that help the model learn from data. To train them, you need to feed in massive amounts of data and perform countless calculations, all at lightning speed. This requires a huge amount of computational muscle. Training is by far the most energy-hungry part of the process. It can mean thousands of GPUs running flat out 24/7 for weeks or even months at a time, all generating heat and demanding constant cooling. To put it in perspective, a single training run for a model like GPT-4 can use more electricity than hundreds, sometimes even thousands of homes do in an entire year. And it doesn't end there. Every time a new model is developed or an existing one is updated, the whole energy-intensive training process starts all over again. But even after training, the energy demands continue. Every time you ask an AI a question, the model has to run or perform inference, which also requires significant computing power. One AI query can use 10 or even 100 times more power than a regular web search because it's crunching through complex algorithms and massive data sets in real time. With billions of AI queries happening every day, the total energy use adds up incredibly fast, putting more strain on our power grids. As AI gets built into more and more devices and services, experts predict that internet energy use could skyrocket in the coming years. Think of a regular search as filling a glass of water, quick, simple, and not very demanding, but an AI query is more like flushing a toilet. It uses a lot more resources and the impact is much bigger. Now multiply that by millions or even billions of queries every minute, and you start to see the true scale of the challenge. The hardware behind AI must always be on, cooled, and ready to respond instantly, which means a constant draw of electricity and a need for powerful cooling systems. This non-stop readiness, combined with the sheer computational power required, makes AI's appetite for energy unlike anything we've seen before in the tech world. That's why AI is now a major driver of the world's growing energy crisis, and why finding greener solutions is more urgent than ever. This surge in electricity demand is straining both our power grids and the environment. Grids were built for slow, predictable growth, not for the sudden spike from AI data centers. In places like Northern Virginia, the grid is maxed out. New data centers are on hold because there's not enough power. Upgrading infrastructure is slow and costly, creating bottlenecks. Environmentally, tech companies have led on climate action, buying renewables and aiming for carbon neutrality. But AI's rapid growth is outpacing clean energy supply. When renewables can't keep up, grids fall back on fossil fuels, undermining climate promises. Even if companies buy renewable credits, their real-time demand can trigger gas or coal plants. It's a collision of ambition and reality. To meet this challenge, big tech is eyeing nuclear power. Nuclear is carbon-free and runs 24/7, perfect for data centers. The focus is on new tech like small modular reactors, SMRs, smaller, safer factory-built reactors. Tech leaders are investing in SMRs, hoping for dedicated clean power next to data centers. There's also nuclear fusion, the holy grail, with huge investments and ambitious timelines. Microsoft even signed a deal with a fusion startup, aiming for grid power by 2028, but nuclear is risky, SMRs are unproven, public perception is wary, and fusion is still experimental. Regulatory and cost hurdles remain high. Betting on nuclear means betting on breakthroughs. Still, for city-scale, constant clean power, nothing matches nuclear's potential. That's why it's back on the table. But it's not the only strategy. The other big play in the energy transition is a massive push for renewables, an all-in effort to harness the power of the sun and wind on a scale we've never seen before. Solar and wind energy are being deployed at unprecedented levels, with entire landscapes transformed into fields of clean power. Tech giants like Google, Amazon, and Microsoft are now the world's largest buyers of clean energy, using their influence to drive the market forward. They're signing long-term contracts called power purchase agreements to fund enormous renewable projects that might not exist otherwise. These aren't just rooftop panels, they're sprawling solar and wind farms, sometimes built right next to the data centers that need the power most. The goal is ambitious, to match every bit of energy used with clean generation, tracked in real time, even hour by hour. Renewables are not only cleaner, but they're also cheaper and much faster to build than nuclear plants, making them the go-to choice for rapid expansion. Public support for renewables is strong, with communities rallying behind new projects and celebrating the shift to cleaner energy. But there's a catch. Renewables are intermittent. The sun sets, the wind dies down, and energy production drops. Data centers, which power the digital world, need a constant, reliable supply of electricity day and night. That's where battery storage comes in, acting as a crucial bridge to store excess energy and release it when needed. But right now, batteries are still expensive and their capacity is limited, making it hard to rely on them alone. There are other hurdles too. Renewables require a lot of land, and building new transmission lines to connect all this clean power is slow and complicated. Renewables are absolutely critical, but they can't solve the entire problem by themselves. The race is on to build enough renewable capacity fast enough to keep up with the explosive growth in energy demand, especially from AI and data centers. It's a straightforward, logical solution, but it's still incomplete and leaves important gaps. We need to think bigger and look for additional answers to fill those gaps. So what else is on the table? What new ideas and technologies could help us reach a truly sustainable future? Let's look at the next frontier in clean energy innovation. Big tech is also betting on experimental solutions like enhanced geothermal energy. By drilling deep into the earth, they hope to tap constant clean power. Google is already piloting this in Nevada. Geothermal offers 24/7 energy with a small land footprint. If it works at scale, it could be a game changer. Another idea, off-grid self-powered data centers, sometimes paired with SMRs. This would bypass grid congestion and give companies total control over their power. But these approaches are risky, expensive, and raise regulatory and safety questions. Still, the willingness to try bold ideas shows how urgent the energy hunt has become. The future may depend on these bets paying off. Here's the uncomfortable truth. Right now, much of AI's new power demand is met by fossil fuels. Building new nuclear or renewables takes years, but AI's demand is immediate. Utilities are adding natural gas plants to keep up, especially in places like Georgia. Tech companies' demand is driving this, even if they aren't building the plants themselves. This clashes with their green promises. On paper, they buy enough renewables, but in reality, their data centers often run on gas or coal when clean power isn't available. The gap between accounting and reality is growing. AI's scale is making this problem much bigger. It threatens the green reputations tech giants have built. Moving fast risks breaking their own climate promises. Is AI just the villain here? Not entirely. The same technology causing the energy crunch could help solve it. Tech companies are racing to make AI more efficient. Better chips, smarter algorithms, smaller models. Every new chip generation does more with less power. Software tricks like quantization and pruning shrink models without losing performance. Smaller, smarter models mean less energy use. AI can also optimize power grids, forecast renewable output, and even help invent better batteries. So AI isn't just the problem, it could be a key part of the solution. The race for efficiency is as important as the race for power. Can AI help clean up its own act? We're at a crossroads. AI promises breakthroughs in science, health, and creativity, but it's powered by a shocking amount of electricity. Tech giants know the risks and are investing billions in clean energy, nuclear, and efficiency. Their efforts are unprecedented, but the challenge is timing and scale. Can they build enough clean power fast enough, or will AI's growth be fueled by fossil energy for years? Their choices now will shape the global carbon budget. The trillion-dollar question, can big tech power AI's future without breaking climate promises? There are no easy answers. Success depends on innovation, investment, and real commitment. As users, we're all part of this story. The magic of AI isn't free, so let's keep asking, where does the power come from?